Just look at this thing. It is sleek, it's silent, and it is unbelievably fast. But, this isn't just about the future of driving. This is a symbol of a massive global transformation, a total reimagining of energy and power.
So what's really at the heart of this whole revolution? I mean, what's the one single ingredient that makes all of this, well, possible?
You've probably heard of it, but you might not know its incredible story. We're going to dive into the epic journey of lithium, the surprisingly humble element that has somehow become the key to our entire electric future.
I mean, it feels like this happened overnight, right? Just a few years ago, electric cars were kind of a novelty, a niche thing for early adopters. Now, every major car company is racing to go electric, and EV sales are just exploding all over the world. The science experiment is officially the real deal.
So, how did we get here? How did this happen? Well, this entire multi-trillion-dollar shift, this move from gas tanks to battery packs, it all hinges on the really unique properties of one single, super lightweight metal.
For decades, lithium was basically a supporting actor. It was used to make heat-resistant glass, industrial greases, even some pharmaceuticals. Important stuff, sure, but not exactly world-changing. But look at the picture today. It is now the star of the show. It's the indispensable core of the batteries in EVs, in massive energy storage grids, and in every single phone in every single pocket.
And this chart, wow, this just illustrates the new reality perfectly. Look at this breakdown. 2/3 of all lithium demand now comes from EV batteries. What's absolutely wild is that as recently as 2016, over half of all lithium was for those other, more traditional uses. The script has completely flipped in less than a decade.
This incredible, skyrocketing demand has kicked off what is basically a modern-day gold rush. But instead of gold, the treasure is this silvery white metal. So where does it all come from? Let's follow the trail.
It's a really complex global journey, but we can break it down into 4 main steps. First, it starts with miners who pull lithium from the earth and create a concentrate. Then, that concentrate goes to these specialized refiners who purify it into battery-grade chemicals. From there, battery manufacturers create the individual cells, and finally, those cells get assembled into the massive battery pack that powers your car. From the mine all the way to the motorway.
Okay, here's where the story gets really, really dramatic. This chart compares our current global lithium supply to what we think we'll need in just a few years. Get this, by 2030, the amount of lithium needed just for electric vehicles will be more than 3 times our entire global supply today. Let that sink in. That is a staggering, staggering challenge.
And meeting that demand is really complicated by geopolitics. The lithium market isn't this wide open field. It's what you'd call an oligopoly. A tiny handful of companies control the vast majority of production. And that production is concentrated in just a few places, like the salt flats of South America and the hard rock mines of Australia, regions that are facing their own pretty intense social and political challenges.
And this brings us to a really critical question. We're all chasing this electric dream to save the planet, right? But what is the real price of all this progress? Is this green revolution truly green at every single step of the way? Because behind the silent hum of an electric car, there's a much more complicated, and sometimes a much, much louder story being told.
Creating these batteries isn't magic. It's chemistry. Now, this looks complicated, I know, but the key takeaway is actually pretty simple. Turning raw lithium into the sophisticated material that can power a car requires multiple, very energy-intensive chemical steps. It's a complex industrial process, and it has a real environmental footprint.
And that environmental dilemma, well, it starts right at the source. In places like the Atacama Desert in Chile, one of the driest places on Earth, traditional lithium extraction involves pumping up enormous amounts of brine and just letting the water evaporate. This puts an immense strain on water resources, which impacts local ecosystems and the indigenous communities who have lived there for centuries. It's the central irony, isn't it? Solving one environmental problem could be creating another one somewhere else.
So this is the challenge. If lithium is the hero of our story, it's a hero with the flaw. For this revolution to be truly sustainable, our hero has to evolve. And the good news is that evolution is already happening.
So meet what could be the next chapter in this story, direct lithium extraction, or DLE. The easiest way to think of it is as a set of sophisticated chemical filters. Instead of evaporating away all that precious water, DLE aims to pull the lithium directly out of the brine, which can then be returned underground. The promise is that it will use less land, way less water, and be much, much faster.
At the very same time, scientists are looking beyond lithium entirely, and the most promising alternative right now seems to be the sodium-ion battery. I mean, sodium is cheap, it's incredibly abundant, it's in table salt, and it could be perfect for energy storage or even for more affordable EVs. It's not about replacing lithium overnight, but it is about creating a more diverse and resilient energy future.
And you know, perhaps the most powerful solution of all is one we already know really well: recycling. Every single battery contains valuable metals like lithium, cobalt, and nickel. Creating a true circular economy, where old batteries become the raw material for new ones, is absolutely essential. It'll reduce our need for new mining and solve a massive waste problem before it even really begins.
The story of lithium is really the story of our time. It's about innovation, it's about unintended consequences, and it's about the relentless search for better solutions. Lithium is the element that enabled our current electric revolution for sure. But the technologies we're developing today, from DLE to sodium-ion to advanced recycling, those are going to define the next one. So lithium is today's hero. What will be tomorrow's?